Hi everyone, it's Joe. Welcome to week 4 of PC Neurobiology in our online format. Today we're going to look at a very interesting paper by Gajdusek and colleagues. I'm probably mispronouncing the name. It's Hungarian in origin. What this group did was carry out a very early study on what are now known to be prion diseases. That is, a group of neurological disorders caused by a protein called prion. We'll get to that in a bit. But what this group did was study a neurological disorder that occurred in a group of people called the Four Tribe, which live in Papua New Guinea. It's just north of Australia. The study was carried out in the 1960s, and the disease was termed Kuru. It is fatal. It's characterized by a spongiform brain that can be observed at autopsy, and there are a number of symptoms that show up as the disease manifests itself, and those include progressive ataxia, incoordination, withdrawal, and terminal inanition, which is tired or exhausted is my interpretation of that. The disease is also familial, that is, it occurs within families, and oftentimes I think of genetic disorders when the term familial is used. In this case, the disease was transmitted through cannibalism. So it turns out that the Four Tribe had a religious ritual in which they would eat parts of their deceased relative, and in doing so, by eating the spongiform brain, the diseased brain, they would transmit the disease from their dead relative to themselves. It turns out years later, the scientists convinced the Four Tribe to stop the cannibalism, and within a generation the disease was gone. Okay, so what did this group do? Well, it turns out that for part of the year the scientists would live with the Four Tribe, and they must have gotten to know members of the tribe because at some point they had access to brain tissue of individuals that died of Kuru. So they took human brain tissue from individuals that died of Kuru, and they say that they injected it into the brain of chimpanzees. And 7 chimps contracted a form of Kuru. That is, they experienced the symptoms, and they say that the symptoms occurred between 1.5 and 2.5 years, and that the symptoms manifested, they followed the symptoms from 3 months to 9 months, and then they sacrificed the animals. Now it turns out that they also injected human Kuru brain tissue into the brains of a whole host of other organisms, and there's a huge list in the paper, but it turns out the chimps were the only ones that were susceptible to the disease. They also say that one chimp had no symptoms, and they also took normal human brain tissue from individuals that died of other diseases, and they injected that into a control group of chimps, and those chimps were fine. Finally, after they sacrificed these chimps, they injected, let's see if I can get this to work, they injected 3 more chimps with brain tissue from these chimps, from the sick chimps, and 2 came down with Kuru. So they were able to show that the disease-causing agent is transmissible from humans to chimps, and then from chimps to chimps. And these 2 chimps showed symptoms instead of beginning at 1.5 to 2.5 years, they began to show symptoms at about a year. One was 11 months, and the other one was 12 months, so exactly a year. Whoops. Oh, my pen won't work. There's a couple of other interesting things to mention. First of all, he did this work at the National Institute of Neurological Diseases and Blindness, which ultimately became the National Institute of Neurological Disorders and Stroke, which is where I did my my postdoc rather, with Tom. And so I worked in the same building that this work was done in. They had a big animal facility there. Of course, I didn't overlap with this group because this was, 30 years earlier anyway. Also in the paper, they concluded that the infectious agent was likely to be a slow-acting virus. And of course, we now know that this is caused by a protein called prion. And we're going to see in the paper next week by Stanley Prusner that he laid out a beautiful argument as to why he believed it was a protein. And indeed, it is a protein, and he won the Nobel Prize for the work. The other interesting aspect of this paper is that Gajdusek was given the Nobel Prize for this work. I mean, it's groundbreaking to be able to show the transmission of the disease from human to chimpanzees and chimp to chimp, of course. And, there are other examples like, I think Ebola, right, was chimp to human. At any rate, it was important to our understanding of how infectious agents can be transmitted from species to species in this particular case, but also within the species. It turns out that under the auspices of education, Gajdusek also brought young children from the Four tribe, both boys and girls, but mostly young boys. And once in the States, he sexually abused them. And so he went to jail for child abuse, for sexual abuse of the children. And finally, of course, as we said, he got the story a little bit wrong with the virus idea, but I think that's understandable. Okay, you guys, that's it for today. That was a really quick one, but please read it over. It's a short paper, but an important one, obviously, and very interesting work, I think. And I know you already know about fatal familial insomnia, obviously. There's also Creutzfeldt-Jacobs. Those two, along with Kuru, are in humans. There's also mad cow disease, right, in cows, and scrapie in goats and sheep, and there's a few others that we're going to take a look at, all caused by the same exact protein in the different species. So the cow form, the sheep form, the human form of that particular protein. So anyway, have a great Easter, you guys. I hope you're safe and well, and I'll see you hopefully at the Zoom meeting on Thursday, and if not, I'll talk to you next week. See you then. Bye-bye.